Hi, today we're going to look at antiderivatives. Now antiderivatives can be kind of considered the inverse operations of derivatives, and we have a special notation for an antiderivative right here. We have this big S, and inside we have some function. Not really a function, we'll talk about that in a minute, and we get this little dx right here. But before we start, let's talk about where antiderivatives come from. If we have a function, let's say we have the function y equals, let's say, x squared, and I take its derivative. I get dy dx equals 2x. Now, I can write this as a differential by multiplying both sides by dx. I get 2x dx. And this is what we call a differential right here. Now, what I want to do is I want to go backwards. Well, what if I have my derivative of 2x and I want to find out what the original function was? Well, that's where we get antiderivatives. So what we do, I start with my differential. dy equals 2x dx. And we have this special notation to do this. I take what's called the antiderivative. In other words, I put this right here. This is called an integrand. This symbol right here is called an integrand. And what it means is I want to do the exact opposite. Now, this over here we're going to talk about way later. That just becomes the function itself, y. What's the inverse of the derivative of y? Of dy is just y. Because how did I get dy? I took the derivative, dy. So I just get y back. Over here, this is what we're going to be spending a little bit more time on today. To take the antiderivative, I'm going to do the exact opposite of what I did to do the derivative. So I write out my 2x. Now, beforehand, I dropped my power, right? And then I subtracted 1. We're going to do the opposite. So instead of subtracting 1 from our power, we're going to add 1 to our power. And that gives me 2. And I put that same power on the bottom, 2. Now there's also going to be something else we're going to add here, a constant. We'll talk about that later on. So I'm going to get y equals 2x squared over 2 plus c1. c1 is just some arbitrary constant. So I'm going to get this, just x squared plus c1. So that's called, this right here is called the antiderivative. Right here. That's the antiderivative. Now, what is c1? Well, remember, my original function was y equals x squared. But could there have been a constant here? Yeah, it could have been like plus 3. Well, if it was plus 3, the derivative is 0. So we put this constant here because we don't know if there was a constant or not, so we have to put it there. Because when we take its derivative, we're going to get just 0. So that's why we have that constant here. So let's take a look at some practice problems. Let's try taking the antiderivative of something a little bit more fun. 3x squared plus 4x minus 1 dx. Now, some people like to have parentheses around these. They're okay to do. Now, what this is saying, the dx, remember, comes from my differential. In other words, what it's telling me is that this inside is a derivative. That's a derivative of some function. I just want to find out what the original function was. So I'm going to use my power rule for antiderivatives, and it's basically this. X to the n dx becomes x to the n plus 1 over n plus 1 plus our constant. That's our rule we're using here. And if I do so, I'm going to take this 3x. If I add 1 to the power here, I get 3, and I put that same 3 over the bottom, plus 4x. Again, there's a 1 up there. I add 1, that becomes 2 over 2 minus, and this just becomes 1x. Don't forget your constant, because remember that's a derivative. There might have been another constant there. So my function was originally x cubed plus 2x squared minus x plus c1. Very easy to do. Now, one of the sad things and happy things is there is no product rule and there is no quotient rule. So if I have something like a square root of x in antiderivative x plus 1 times x minus 3 dx, I'm going to have to expand this. So we get x squared minus 2x minus 3 dx. And now I take the antiderivative. So we would have to expand first. So my rule tells me to add 1 to my power, and then I divide it by that same power. Minus 2, add 1 to the power, divide it by that power. Minus, now, why do I get a 3x here? Because remember, this was an x to the 0, so if I add 1, I get x to the first. You don't have to put it over 1 if you don't want to. Plus C1. And I can leave it or I can clean it up a little bit. I get x cubed over 3 minus x squared minus 3x plus C1. And there's my antiderivative. You can easily check it. Take the derivative, you do get x squared minus 2x minus 3, and that just goes to 0. Very easy. So let's take a look at a slightly harder one, number 3 here. Okay. Now for a problem like number 3, let's have a little bit of fun. Let's try this. 3 times the square root of x minus 1 over 2 times the cube root of x dx. Ew. Just like derivatives, I'm going to rewrite this. So I get 3 x to the 1/2 minus, and I'm going to write this as 1/2 x to the negative 1/3 dx. And again, you can put parentheses around there if you like. So my rule, now I'm ready to take the antiderivative, but what my rule says to do is this becomes 3, and this becomes x. Now if I add 1, be very careful, that becomes 3/2. So I put that over 3/2. You get very quick at this. Minus 1/2. And again, if I add 1 to my power here, I get negative 1/3 plus 1. That's a positive 2/3 over 2/3 here plus C1. Now the only thing is I don't like these complex fractions, so a quick way to do it, I can invert and multiply. You can get really good at this, by the way. This becomes 6 over 3 x to the 3/2 minus, if I flip here, I get 3 over 4 x to the 2/3 plus C1. And you can make that a 2 if you like. Very easy to do. And I know what you're thinking. What about trig? Well, before we get to trig, let's take a look at this one right here. If I have the antiderivative of, let's say, x plus 3 over the square root of x. Now, there is no quotient rule. Okay? There is no quotient rule. But what I can do is I can split this. Split your fraction. This becomes x over x to the 1/2 plus 3 over x to the 1/2 dx. And I can rewrite this. X to the 1/2 plus 3 x to the negative 1/2 dx. Now I need that dx there because it's telling me it's still a derivative. When I take the antiderivative, add 1. I get x to the 3/2. Now a quick way to do it, instead of saying 3/2, I can, over 3/2, I can just invert, multiply, and go 2/3. Plus, now this becomes 3x, and if I add 1 here, 1/2, so I'm really multiplying this by 2. Instead of doing it over 1/2, plus my constant. And we'll rewrite this 2/3 x to the 3/2 plus 6 x to the 1/2 plus C1. And there we go. Alright, now, this one's getting a little bit lengthy, so what I'm going to do in the next one, I'm going to take a look at some trig ones. So, take a look at some trig ones, and also take a look at how do we solve for C. Okay? So, take a look at the next video for that.